Hey there, Mr. Weaver here, and this is 8th grade, Module 4, Lesson 2, Slope of a Line. After this lesson, you need to be able to identify the slope of a line and interpret it as the rate of change within the context of the problem. Let's learn. Slope of a line. The term slope is used to describe the steepness of a line. As we saw in the previous lesson, slope is the rate of change between any 2 points on the line. It's also called the unit rate or the constant rate of change. The vertical change, which is the change in the y values, is called the rise, while the horizontal change, or the change in the x value, is called the run. So the slope ends up being the ratio of the rise to the run. In linear relationships, our slope is constant. So as we are going through this, we will see slope is equal to the rise over the run. So how much is it changing going up and down, divided by how much is it changing going left and right. When we're talking about slope, we can have a positive slope or a negative slope, and we determine it by reading from left to right. So a slope that is pointing upward from left to right is going to be a positive slope, while a slope that is pointing downward from left to right is going to have a negative slope. So as we are going through this, it's going to be super helpful to be reading left to right. Let's learn. Find slope from a graph. The slope of a line can be found from a graph by finding the ratio of the rise to the run between any 2 points on the line. And we saw this in the last lesson as well when we were finding our constant rate of change. So here we're given 2 points. How is it changing vertically compared to horizontally? So vertically, it went up 3 units. So we would put it as positive 3. Horizontally, it went to the right 4 units. So our horizontal change would be 4. When we're reading the rise and run from a graph, again, rising up is positive, while a rise down, even though that kind of doesn't really make sense, is negative. A run to the right will be positive, and if we happen to come across it, a run to the left will be negative. But in general, if we're working from left to right, then we might as well just always go to the right and keep our run as a positive number, which is what I am going to do in all of our examples. So here, our slope would be 3 over 4, or 3/4. Example 1. Find slope from a graph. The graph shows the cost of muffins at a bake sale. Find the slope of the line. So to calculate the slope, we're going to find the vertical change, which is our rise, compared to the horizontal change of the run between any 2 points on the line. We're given the points 2, 4, and 3, 6. There's also a point down here at 1, 2, and there would be one up here at 4, 8, and at 5, 10. I'm looking for the places where the line would go through the intersection of the grid lines that I was given. So they gave us 2, 4, and 3, 6. How does the change vertically compare to the change horizontally? So vertically, the price went up by $2. Horizontally, the number of muffins increased by 1. So in this case, our slope would be 2 over 1, which is 2. The slope of the line would be 2. And if we were thinking about what this means in the context, that would be the unit rate, or how much did it cost for one muffin. It would be $2 for one muffin. So as we buy one more muffin, our price goes up by $2. Check your understanding. Find the slope of the line. Here they give you 2 points. So 1 is there and 1 is there. Use those 2 points in your calculation. Pause the video now and complete the check. Check your answer. You should have found that the slope was 2/3, or if you calculate it out as a decimal, you could say 0.6 repeating, but in general, we're going to see slope as a fraction. So to figure it out, going from one point to the other, I had to go up 2 units. There's my vertical change, and over 3 units. Remember, you're counting the number of spaces, not the lines. So up 2 spaces, over 3 spaces, 2 over 3. The slope of this line was 2/3. Example 2. Find slope from a graph. The graph shows the amount of water in a leaking bucket over time. Find the slope of the line. So the fact that the bucket is leaking tells me that the amount of water should be going down. That's generally what happens in a leaky bucket. And we can see in our graph this is true. If the line is the amount of water, it is going downward over time. Just like before, we're going to use the 2 points that they tell us. So 3, 5, and 9, 1. How does the graph change? Well, to go from one to the other, I would have to go down 4. So when we're going down, we're going to make it a negative number. Down 4. And we're still going to the right 6 units. So negative 4/6. This is the slope of the line from what we are given, but since it's a fraction, we can simplify it. Negative 4/6 would simplify to negative 2/3. So the slope of this line in simplest terms would be down 2/3, negative 2/3. And we can see, had we included this point right here, our slope then becomes down 2/3. So after all that, our slope is negative 2/3, or we can swing that negative out front and put negative 2/3. They both mean the same thing. Check your understanding. Find the slope of the line given in the graph. Pause the video now and complete the check. Check your answer. You should have said negative 4/1, or we can just write negative 4, since negative 4 divided by 1 is negative 4. Our vertical change, we had to go down 4, and we only went 1 unit over. So negative 4/1. Let's learn. Find slope from a table. So we can determine the slope from a table by finding the ratio of the vertical change to the horizontal change. Now, we could plot these points on a graph and visually see the vertical change by horizontal change, but vertical change is talking about the changing in the y value, where horizontal change is talking about the change in the x value. So if we're looking at our table here, between the number of transactions and the balance in a bank account, we can see that every 3 transactions, the balance goes down by 30. So our slope then would be our unit rate. How much is it changing every time? It went down 30 in 3 transactions. So again, we're doing y on top, x on the bottom. Then if we want to reduce that, it went down 10 every 1 time. So the slope in the situation would be negative 10 because we are losing or spending $10 every transaction. So in general, if we need to find the slope from a table, then we're just going to check how the y is changing. It's usually on the right side or on the bottom, divided by how much the x value is changing each time. And doing that, we'll figure out our slope. Example 3, find slope from a table. The points given in the table lie on a line. Find the slope of the line, check your solution. So here we can see x goes from negative 6 to negative 2 to 2 to 6, while y goes from negative 2 to negative 1 to 0 to 1. So we can pick any 2 points here. These are all just coordinates. So I have negative 6 and negative 2. If I had a graph, right, negative 6, negative 2 could be somewhere over here. And then I'd have negative 2, negative 1, 2, 0, 6, 1. Not completely accurate, but you can kind of visualize what's happening. We can choose any values here and figure out how it is changing. We just need to make sure that we're doing the change in the y, which is our vertical, divided by the change in the x, which is our horizontal. So let's choose the first 2. So negative 6, negative 2, going to negative 2, negative 1. So let's figure out the y first. We went from negative 2 to negative 1. Now, for these next couple examples, we're going to use the coordinates and do some subtraction. So what we're going to do is take the end and subtract where we start. So we ended at negative 1, and we're going to subtract where we start, which was negative 2. When we subtract this, we end up with 1. And we can see, just looking at our y values, each time it's going up by 1. So the top value, our change in y, would be 1. Our x values ended at negative 2 and started at negative 6, meaning negative 2 minus negative 6 was positive 4. We can see each time that it just went up by 4. Up by 4. So the y values were going up 1 each time. The x values over that same time frame were going up by 4. So our change in y over our change in x was 1/4. So after all that, the slope of the line is just 1/4. If you find it easier to subtract the coordinates, do it that way. If you find it easier just to figure out from the table how it's changing, feel free to do it that way as well. To double check if we're finding the slope, we can just use 2 other points in the table and see if we come up with the same thing. Since we're dealing with a straight line, the slope should be constant, meaning the same throughout. So if we choose, let's say 2 to 6, 0 to 1. Again, it went up 1, up 4. Our slope is still 1/4. No matter how we're doing it, we're getting a slope of 1/4. Check your understanding. These points in the table lie on a line. What is the slope of that line? Pause the video now and complete the check. Check your answer. You should have found 1/2, or you could have done 0.5. So to get this, I'm going to just show I'm using the table. So 3 to -1 went down 4. This went down 4 again. This went down 4 again. So no matter what, my y value is always going down 4. How is my x value changing? 1 to -7 went down 8. -7 to -15, down 8. So each time, -4, -8, the two negatives make a positive, so 4 over 8 would reduce to just positive 1/2. A negative divided by negative is positive. Let's learn. Find slope using the slope formula. You can find the slope of a line from any 2 points on the line using what's called the slope formula. It does not matter which points, as long as you define them as x1 and y1 and x2 and y2. However, once you define which is which, the coordinates of the points must be used in the same order. So for example, if you used x1 first, then you have to use y1 first. If you use x2 first, you have to use y2 first. Other than that, it doesn't matter which points you use. So we kind of just saw the slope formula in action when we were subtracting. How it works, we take the y coordinate of one of our points. So if we notice, like, I'm going to kind of write it sideways. Here's one coordinate, and here's our other. Notice the y is on top, x is on the bottom, so maybe it'd be a little bit better to put the comma over here. Either way, we're just subtracting the y coordinates and then subtracting the x coordinates to find our slope. In this picture, we can see how we can find the slope using our points 1, 3, and 5, 6. So we can see just from this picture, it went up 3 over 4. So I just know from my previous learns and examples that my slope should be 3/4. It went up 3 over 4. Let's see what we get when we use our coordinates. First, we need to define which one is x1, y1, and x2, y2. So let's say that this is x1, y1, this is x2, y2. Since both of these numbers are larger, and I'm subtracting, I'm going to do my easy subtraction in my head. 5 minus 1 is easier to do than 1 minus 5. We'll get the same answer either way, but it's easier for me to do, so I'm going to choose this as the one that goes first. So I'm going to take my change in y values. So y2 was 6, y1 was 3, and I'm going to subtract them. 6 minus 3 is 3. Then I'm going to do the same for my x values. I started with this upper one, so 5 minus 1 ends up being 4. Just by subtracting in the same order, I was able to also figure out and get the same slope that I could get by counting. It's another way that we can do it, especially if the values are pretty far apart and counting does not necessarily make sense, or if we are just given the coordinates without it being graphed first. Example 4. Find the slope using the slope formula. Find the slope of the line that passes through R, which is at 1, 2, and S, which is at -4, 3. Check your solution. So given our slope formula, M, which is the slope, is y2 minus y1 divided by x2 minus x1. We're just subtracting the coordinates. Let's say that the first point we are given was x1, y1. So here's my x1, y1, and S is going to be x2, y2. I got to decide which order I want to put them in. So I'm going to use the order that works best for subtraction. The -4 and 1 don't really lend itself, so that doesn't help me with an order. But 3 minus 2 is easier than 2 minus 3. So let's subtract that order first. We can do 3 minus 2. Because I did 3 minus 2, I have to keep the same order. -4 minus 1. 3 minus 2 is 1. -4 minus 1 is -5. So just by subtracting my coordinates, my slope becomes 1 over -5. Or I can just put -1/5. In order to check to see if we are coming up with the correct slope, we can switch the 2 points around. So we originally said that 1, 2 was x1, y1, and -4, 3 was x2, y2. If we just switch those and subtract the opposite, we should still get the same slope. So notice here, we just switched. Instead of it being 3 minus 2, 2 minus 3 is now -1. Instead of it being -4 minus 1, I have 1 minus -4. This becomes +5. I have the same slope when I switched it. I know I did it correctly. My slope is still -1/5. Check your understanding. Find the slope of the line that passes through -3, 2, and 5, -4. Pause the video now and complete this check. Check your answer. You should have said -3/4 or -0.75. but our fraction answer is probably the one you should have. If we were to visualize and graph this, we have -3, 2, which would be somewhere up here, and 5, -4, somewhere over there. So if I was drawing a line to connect those 2 points, I at least know my answer should be negative since I see a downward line going from left to right. So let's subtract and figure out. Let's start with our y coordinates. 2 minus -4 or -4 minus 2. Either way, it doesn't really matter. I'm going to do -4 minus 2, and I get -6. Since I did the second one first, I have to keep the second one first. 5 minus -3, which is negative, add, so 5 plus 3 is 8. I get -6 over 8, which reduces to -3/4. So this was going down 6 over 8, or down 3 over 4, down 3 over 4. Let's learn zero and undefined slopes. So far, the slopes we've looked at either had a positive slope or a negative slope. Sometimes, though, you are going to get either horizontal lines or vertical lines, and they have neither a positive nor a negative slope. Horizontal lines have a slope of 0 because it is not going up or down at all. The change in y is 0 for every time that you go over. Vertical lines, on the other hand, have what's called an undefined slope, and we'll look at why that is in one of the examples. Example 5, 0 slope. Find the slope of the line that passes through -3, 4, and 2, 4. So we can use our slope formula here, or we can just look at our line. They're using the slope formula and subtracting our coordinates. So if we're subtracting our y coordinates, 4 minus 4, and then subtracting our x coordinates, 2 minus -3, 4 minus 4 is 0, 2 minus -3 is 5. So this went up and down 0, and it went over 5. If we have 0 divided by anything, you have 0 items out of the 5 that you need, you have nothing, you have 0. So if we have a horizontal line, it did not change going up and down at all, we have a 0 slope. So if we have a horizontal line, our slope is going to be 0. Check your understanding. Find the slope of the line that passes through the 2 points given. Pause the video and complete the check. Check your answer. Hopefully you said that the slope here was 0. If we look at our change in y values, it went from 5 to 5. There was no vertical change. That would go on top. -4 to 2 is 6 in our horizontal change, but since there's no vertical change at all, our slope is just 0. Example 6, undefined slope. Find the slope of the line that passes through 1, 3 and 1, 0. So here, if we're going through, we can see that we have it graphed. We're using our slope formula and subtracting. We ended up going up or down 3, in this case down 3, but we moved 0 to the left or right. So essentially, somehow the item or object moved 3 spaces down and no time had passed. What we're ending up doing is trying to divide by 0. We can't be dividing by 0. So in this instance, the slope of the line is undefined since we're trying to divide by 0. Check your understanding. Which of the following represents the slope that passes through the given points? Pause the video now and complete the check. Check your answer. Hopefully you picked D, -2, 3 to -2, 8. That would have changed by 5 going vertically, but subtracting those x values, I get 0. It had no horizontal change. It is an undefined slope.